We know how to use and understand a linear model once we have the equation to describe it. But how can we come up with the equation? Well, in order to write down the equation, we need to know the slope and the intercept. If we're just given the slope and the intercept, right, so the slope is the number m, the intercept, so the y-intercept is the point 0, 1, so that's telling us that b is 1. We can directly write down the equation in the form y equals mx plus b by just dropping those numbers into their positions. So y equals, the slope is negative 2/3 times x plus the intercept is 1. Once we know the slope and the intercept, we can just drop those into an equation. Of course, usually we don't directly know the slope and the intercept. We need to find those from somewhere. Maybe we have a graph that describes our function. Recall that when we drew a graph given the slope-intercept form, the denominator of the slope told us how far to go to the right. The numerator told us how far to go up or down, depending on whether it was positive or negative. Well, we can work backwards from a graph to an equation by saying, to find the slope, we pick 2 points, say these two. We can pick any 2 points as long as they're points that we can read nicely. We take the distance to the right to go from one point to another. This is 3. And then, in this case, to get to the next point, we have to go downward. So this is negative 2. In this graph, the slope is negative 2 over 3. The intercept is the point where we cross the y-axis. So this is the point 0, 4. Our intercept is the number 4. And so our equation in slope-intercept form is going to be y equals negative 2/3 x plus 4. Okay, so this is what we do given a graph. If we're just told the slope and intercept, we can just write down the equation. If we're given a graph, we can count out the slope, we can look at the intercept. Now we know the slope and the intercept, we can write down an equation. Okay, let's suppose we're working with something more realistic. Let's suppose instead of just being told directly or being shown an existing graph, we have something like an input-output table. So in this case, we're going to understand the slope to be the distance up or down, so the change in y, over the distance to the right, so the change in x. And then our intercept is the starting value of y, the value of the output when the input is 0. Let's see an example of that. So in this story, the price of admission for a certain music festival has increased at a constant rate since its first year of operation in 1995. The prices are shown in this table. So, how do we know, first of all, that this is even a job for a linear model? Well, in the story, there's a phrase that cues us, and that phrase is constant rate. In particular, we're saying that the price has increased at a constant rate. So this phrase, increased at a constant rate, decreased at a constant rate, changed at a constant rate, this indicates that we want a linear model. So from the story, we know we want a linear model because it says increased at a constant rate. And the words constant rate are the most important part of that phrase. Okay, we can also observe in the table that every time we go down a row, our input increases by 1. Our output, it looks like it increases by 6, right? Definitely 10 to 16 is an increase of 6. 16 plus another 6 is 22. 22 plus another 6 is 28. 28 plus another 6 is 34. Yes, every time we go down a row, x increases by 1 and y increases by 6. So in the table, a constant change in x produces a constant change in y. The slope then is going to be just the change in y over the change in x. So in the table we see each row we have a change in y of plus 6, a change in x of plus 1. Our slope is 6 over 1 equals 6. Now, you might be thinking, okay, what if we skipped some rows, right? What if we said, let's go straight from 10 to 22, that's plus 12. Let's go straight from 0 to 2, that's plus 2, right? What if we just hadn't recorded anything for 1996 or whatever? Well, then our slope would be 12 over 2, which is also 6. One of the features of a linear model is that we get the same slope for any two pairs. So any two pairs of values, we get the same slope. Okay, now we interpret the slope in the context of the story. So the output is the price of admission. So the price of admission has increased at a rate of, so the slope is 6. And then we have the units of the price of admission, which is in dollars. Dollars per. And then we have the units of the input, year. Right, X is in years. The price of admission has increased at a rate of $6 per year. We could also write $6 this way per year. Those are just different ways of writing the same thing. You can use whichever you like better. Now the intercept, that's the value of y when x is 0. So looking at the table, we find where x is 0. We see that the output that year is 10. So our intercept is 10. In the context of the story, right, the price of admission was $10. And now we want to say when x equals 0. So x indicates the number of years since 1995. So when it's 0 years since 1995, that's in the year 1995. So in the context of this story, we want to just say what year it is when we're talking about a time. Okay, and now we can write our function because we know our slope. That's 6. That's the value of m. So 6x plus 10, that's the value of b. That's our equation in slope-intercept form. Once we know the slope and the intercept, we can just write down the equation. Next, I'm going to check that that equation is correct by making sure that y of 4 equals 34. Why y of 4 equals 34? Well, looking back at the table, input 4 gave us output 34. And we didn't really use that in coming up with our equation. So if we have the wrong equation, we're not going to match at that last row. So y of 4, that's 6 times 4 plus 10. 6 times 4 is 24, plus 10 is indeed 34. Okay. Now we're going to use this equation to answer some questions. This next question says, what was the price of admission? So that's asking us about y. In 2015, that's telling us x equals something. We're given information about x and asked to find the value of y. But we're not told the value of x directly. So in 2015, it's how many years since 1995? Well, to figure out the number of years since 1995, we take the year and subtract 1995. So 2015 minus 1995, that's 20. So we've just been told that x equals 20. Okay, now we can put that into our equation. Y of 20 equals 6 times 20 plus 10. 6 times 20 is 120, plus 10 is 130. In 2015, admission cost $130. Okay, so in this example, we were given a table of values and told that we had a constant rate of change, and we were able to use that to write down the equation. In our next example, we're just going to have a story. In this example, we're told a candle begins with a height of 18 centimeters and it burns at a rate of 4.5 centimeters per hour. So, how do we know this calls for a linear model? When we say the candle burns at a rate of 4.5 centimeters per hour, well, 4.5 centimeters is a constant number. And so this is telling us about a constant rate of change. In this case, 4.5 centimeters per hour. Okay, so let's just use the information that we have to get the kind of table we were looking at a minute ago. So the candle starts at a height of 18 centimeters, and then it burns at a rate of 4.5 centimeters per hour. So every time 1 hour passes, as a candle burns, does it get taller or shorter? It gets shorter, right? Every time 1 hour passes, the height is going to decrease by 4.5 centimeters. So after 1 hour, the candle will be 13.5 centimeters tall. After 2 hours, it'll be 9 centimeters tall. After 3 hours, it'll be 4.5 centimeters tall. I'm just subtracting 4.5 centimeters from the height every time I add 1 to the time. So my slope then, my change in y is negative 4.5. My change in x is 1. My slope is negative 4.5. My intercept, I want to find the height when the time was 0. So my intercept is 18. Okay, so here's the punchline of these two parts. We didn't really need the table for that, right? In the story, we were told the slope when we were told the rate of change. Now, figuring out that that needed to be negative is a little bit tricky. We have to use the fact that the height is going to decrease as it burns. And in fact, especially if you often have trouble deciding whether your slope should be positive or negative, it can actually be useful to stop off at a table in between your story and your equation. But nonetheless, the story told us the rate of change directly. It was negative 4.5 centimeters per hour. The story also told us the starting height. Either way, with or without the table, We can get our equation by just dropping in our values of m and b. Negative 4.5 x plus 18. And then we can use that equation to answer questions. For example, we can answer, how long does it take? That's asking us about a value of x. For the candle to burn down to nothing. That is, for the height to reach 0 centimeters. So to get to y equals 0. So we're given information about y and asked about x. We'll plug in the value we're given for y and copy the rest of the equation. And now we have a two-step equation. Notice x is not by itself on one side. We'll need to do algebra. I'm going to start by writing this with the x on the left. So negative 4.5x plus 18 equals 0. We'll subtract 18 on both sides and have negative 4.5x equals negative 18. Right, 0 minus 18 is negative 18. Then we'll divide both sides by negative 4.5. And we get x is positive 4. You can do that division on the calculator. So it takes 4 hours. Okay, so how do we get an equation for a linear model? First, we need to figure out the slope. How do we figure out the slope? Are we told what the constant rate of change is? Then we know the slope. Are we not told the constant rate of change, but we're told at least 2 pairs of values? We'll see some examples like this in a little while. Then we can calculate the rate of change just by doing division. Right? So the slope is the rate of change of y with respect to x. It's going to be the change in y over the change in x. If we're thinking of our pairs of values as x1, y1, so this is one pair of numbers, and x2, y2, so this is another pair of numbers. To find the change in y, we'll subtract the y's. And to find the change in x, we'll subtract the x's. I usually like to do the subtraction in the order where I'm taking the larger x value minus the smaller x value. So I get a positive number in the denominator of that fraction. But it actually doesn't matter what order you go in, as long as you keep the order the same between the numerator and the denominator. So if you say that your starting y value is y1, you have to say your starting x value is x1. Okay, so that's the slope. If we just have 2 pairs, we can calculate the slope by setting up this fraction. What about the intercept? Well, if we're given a story, and part of the story is an initial value, so a value for the output when it's understood that the input value is 0, then we've been given the value of the intercept. If we have a table of values and one of the points has an x value of 0, then we have the intercept. If we have a graph, then b is the y value where the line touches the y-axis. If we can read that point on our graph. Occasionally, we are not given information that lets us immediately determine the starting value. So we don't have a 0 in our table, or we aren't given the starting value, or we can't easily read the y-coordinate where our graph crosses the y-axis. In that case, we'll use the point slope form, which we'll see in a minute. One thing to note is if you're having trouble finding the slope, and especially if you're often getting the sign of your slope wrong, you might find it helpful to go from your story to a table of values, and then from a table of values to your equation. And in fact, that's what I'm going to do in most of the examples here. And later on, we'll also see a way to have the calculator go from a table of values to an equation for you.